So we have all gathered here for design thinking based discussion on how to manage the IO devices in embedded system. So we all know that embedded system is designed to do a specific function. So unlike the general purpose system, the IO devices in embedded system will constantly communicate with the external world. So here the IO devices act as a bridge between the processor and the external world. So the challenge here is that we have to design and manage the IO devices such a way that it is efficient, reliable, and power consumption is low. So you are going to discuss about this challenges and give me a solution by applying design thinking concept. So design thinking is a way of problem solving technique where we consider each and every needs of a human, and it is a human centric approach. So totally we have 5 stages. Stage 1 is empathy, define, ideate, prototype, and testing. So I'll give you 5 to 10 minutes, discuss and get me a good point. So hope you have completed your discussion. You can start providing the solution. So stage 1 is empathy. Yes.
So, so the first part of the design thinking is empathy. So empathy is to understand the user and the system environment. The users like automation engineers, embedded system designers, IoT engineers like healthcare, robotics, and so on. So these users need fast response, accurate data, and reliable outputs. So in these cases, they might face the challenges like low battery, limited memory, and complex hardware interfacing, and some noisy sensor data. So by using these challenges, we have to design a sensor in which has to be inefficient and reliable input output access.
So the next stage is define.
So the second stage of design thinking is define part. So in define part, the main challenges in the embedded system is to efficiently manage the input output devices. So the embedded system normally reads the sensor data, and it should control the output by a real time. So in this, the main problem is that the input output devices may delay due to the memory and processing units. So delay in the input output devices may increase the power consumption, and data accuracy may become low. So this power handling must be designed in such a way that it should be the embedded system should be designed in such a way that it should be low power consumption, efficient and fast and reliable. So and it should be efficient in a manner that it should use a resource constraint. That's
So I'm going to be talking about the ideate part. So from our problem statement, that is, we have to be finding a solution for efficient work of the input and output devices. So for that, firstly, we can choose the systems which are having interrupt-driven transfer mode. Like, for example, if we are taking a program-driven transfer mode, the system will keep on running, and until and unless another external sensor signal comes in, it will just wait for the signal to execute. So in that meantime, the time will be wasted. So if you are using a interrupt-driven transfer mode, the system will keep on doing its work, and then if there is another signal and if that instruction to be executed, and at that time it will carry out its instruction. And the next thing would be we should check for the good communication protocol. So there are various types of communication protocol like UART, PCI, SPI, and I2C. So there are so many communication protocols. So for the design we are using for each sensor is a protocol, and if you are using different devices at once, we will be using I2C. So for each design, we'll be having different protocols. We have to choose it carefully. And then next would be we can use proper filtering process. Like the signals will be having noises in it. So if we don't use the proper filtering process, we may get distortion and unwanted signals. So if you are using a proper filtering process, that system will carry out smoothly.
For real-time data,
Accuracy is really important. And finally, we can use a proper ADC and DAC like converters. So mostly all the sensors will be giving out analog signals, and then the processor will be getting in only the digital signal. So if we are using, we have to use the converters, and that too we have to use it properly. So by choosing the proper ADC and DAC, we can make the input and output devices work more efficiently.
And the next stage is prototype. So in this, we converting our ideas into a working model in the efficiency of input output management and embodied. And in this, in a microcontroller like Arduino connected to the sensors like temperature sensor, humidity, light sensor, we collect the data based on the environment. And the system we process the data and output devices like LED, LCD, etc. And we also, to improve the performance, we use the input interrupt based on input output instead of continuous volume, which help to help from the time. We also using a communication protocols with the RASPC and UVR. And additionally, we have sleep mode and also to reduce the energy. Last stage of the design thinking is the testing time. We can test the functional testing from where the sensor is sensing the device like temperature sensors, it monitoring the temperature and we can use the LEDs. In the real-time application, we can collect the feedback from the user for the power consumption. It may active in the accuracy and it can be in the sleep mode. The data power is efficiency, and we can measure the power efficiency through the sensor. We have advanced model to design the sensor in all IoT devices to manipulate the system work smoothly and reliably.
Thus, as per our discussion, to efficiently manage the IO devices, we have to go with, as Jenny told, we can go with interrupt-driven IO transfer mode and various usage of the communication interfaces, which is power efficient. Proper design of ADC, DAC, we can design and manage the IO devices efficiently. So, thank you all.
Thank you.